So this video here is meant to compare the three main types of functions that we've learned to this point in the class, and compare what they look like, compare what the tables look like, and compare what the situations that they're in look like. So we have the three types. We have linear, we have exponential, and we have, of course, quadratic. Quadratic is a new one here that we just got started with. Okay, so linear functions, exponential, and quadratic. So the equations of each one of these, so linear, you have several equations. You have y equals mx plus b. That's called slope-intercept. You have ax plus by equals c. That, of course, is called standard. And then we have point slope, which is this guy right here. It's minus. Way back first trimester. And then we have exponentials. And in exponential we have a times b to the x. And when you get into higher level, there's something compound exponential, or compounding continuously exponentials. So there's more than one version of that. For the most part, we've just got this version here. And then finally, of course, we have the quadratic, which has three versions also. So we have the standard form again, ax squared plus bx plus c. We have the vertex form, x minus h squared plus k. And of course, we have the factored form. Now, what I want you guys, oops, that's not supposed to be an M. What I want you students to be able to do is to recognize the graph, of course, and recognize that it's linear. Or recognize see the equation, or see the graph and know it's exponential and quadratic. And then, of course, be able to see an equation and know if it's quadratic, or see an equation and know if it's exponential, see an equation if it's linear. Compare them. You have, those are your equations. We can look at it in a table. A table for a linear. And what's special about a table in the linear one is that it is going up or down by a constant number. So this guy right here is a linear. Whoops, that's not supposed to be 11 or 13. I mean, it's supposed to be 14. And the reason what makes it going up and down by a constant is we're adding 3 every time. Add 3. It's a plus here. Plus. Add 3 every time for every 2. And if you're to plot these points, they're going to form a straight line. If you write the equation, the slope is 3/2 x, because it's 3 for every 2x, and we started at 5. So that's a nice generic, simple, linear table. Now a table for, let's do a different color here. Let's go purple. Now a table for an exponential, it can look pretty similar in everything except for we could be multiplying. Let's see these 2, 4, 6. See, that doesn't change. And it started at 5. So everything right now could be linear, it could be quadratic, it could be exponential, doesn't matter. Let's say that we're multiplying by 3, so that's tripling. So now it's going to be 15, and then 45, and now 135. So you're multiplying by 3. So instead of adding 3, we're timesing by 3 every single time. And that is what determines a table, makes a table multiplication, or makes a table exponential. So now the equation of this guy, it starts at 5. I guess I don't want to use green. So let's make it a nice color that goes with it, purple. So it starts at 5. We're tripling. It's timesing by 3. But it's taking 2 units of time. That's where that 2 comes into play. It's taking 2 units of time. So that is an exponential. Now quadratic is a little bit trickier. It's quite a bit trickier. But what you're going to see is the second difference be the same. So over here, in a linear one, this is called the first difference. And it's because it is a degree 1 problem. Degree 1 means that this x has just a 1 for the exponent. So that's why the first difference is constant. Now let's do the quadratic, which is not nearly as cool in terms of the table. But I'm going to write one down here. So this guy is going to go 0. This time it's going to go 1, 2, 3. And when I'm plugging these points in, 0 gave me 5, 1 gave me 7, 2 gave me 13, and 3 gave me 23. So I'm going to do this table 2 different ways. So I'm going to show it with, let's do one more point here, just a 37. Alright, so we're going to look at this table 2 different ways. We're going to look for symmetry, and we're also going to look for the second difference being the same. So this is going up by 2. And then from 7 to 13, it's going up by 6. 13 to 23 is going to go up by 10. There's a pattern here. This one's going to go up by 14. And without even knowing what the function is, I know this next one's going to go up by 18. So at 5, this is going to be now 55. Okay? Now, to show the second difference, 2 goes to 6, whoops, is going up by 4. This guy's going up by 4. This one's going up by 4. So for those of you good at patterns, the next one's going to go up by 4. So that means that the next one's going to go up by 22. So that's 6, and that makes 77. And the pattern keeps on going. So this is called the second difference. And the reason why a quadratic has that, being a constant, is because this is a degree 2 problem. So degree 2, meaning the highest exponent, is 2. So that's one way to recognize a quadratics table. Let's do one more table for a quadratic. We're going to use the exact same table, but we're going to know something else about it. So this one didn't have any symmetry in it, but if I had 0, 1, 2, then I had negative 1, negative 2, this guy was 5, this guy was 7, I believe it was 13, and over here it was 7, and it was 13. What's cool about this one is I do have the vertex. So this middle is the vertex, because the symmetries here, 7 and 7, 13 and 13, that's symmetry. Now there's another function that has that symmetry that's absolute value, but now to show that this holds true though with the second difference being constant, let's go ahead and go ahead and show this. So this also holds true with the second difference. That's a 13 down here. So 13 to 7 is a drop of 6. 7 to 5 is a drop of 2. 5 to 7 is an increase of 2. 7 to 13 is an increase of 6. So negative 6 to negative 2 is actually an increase of 4. Negative 2 to 2 is actually an increase of 4. And 2 to 6 is an increase of 4. So this is the exact same problem. Now, we could write the equation this, given that we have the vertex. It makes it easy to write this, so I can use the vertex form. So x minus 0 squared, and then the k is 5. Now the only thing I don't know is a at this point. So what I'm going to do is I'm going to plug in a point and find a. So if I plug in 7 for the y and 1 for the x, so 1 minus 0 is 1. If I solve this, I'm going to get 2, because I'm going to subtract this guy across. I'm running out of room on this page here, so 2 equals, and this guy is 1, so 2 equals a. So, right here is a 2. Now this does simplify to be y equals 2x squared plus 5. So that's the table. Now, so you've got table, graphs, So we've already done the graphs, we've done the tables, we've done the equations. The other thing is the situations. So what are the story problems about? Okay, so linear, you see an increase or decrease by the same number. Increase or decrease by the same number. Okay, so something's started at 5 and it's increasing 3 for every 2 hours. So something started at 5, it's increasing 3 for every 2 hours, then your equation would be such. Okay, so that's a linear. In exponential, some key words here, you would see here, it's multiplied by, it's multiplied. That's one way. So you might see the word double, triple, half-life. Those are all 1/2. Those are all multiplied. So if I said it started at 10 and it's doubled every 3 hours, that'd be a situation. If I said the half-life of an item is the half-life is every 12 days, then you've got your equation started at 100 and it's half-life. So that's what you're multiplying by. So that's one way of seeing it, exponential. Or you'll see it an increase by a percent. Okay, increase by a percent. So if you see a percent, that's going to go in that form of the compound interest formula, like so. That's increasing by a percent. So that's a lot of money, all that kind of stuff is modeled by that. Now quadratics are a little bit different. There's not as many, well, there's a lot of applications, but not as many easy applications on this. But anything with flight, a ball going through the air, etc., a bullet being shot, whatever it is, whatever goes up must come down. This is a quadratic. This is gravity. So basically, gravity problems that you'd have. There's also ticket price things where that kind of thing, trying to maximize revenue and costs and all that kind of stuff. But those are what give it away usually is flight and gravity problems, so you know it's a quadratic. An exponential, you see a percent increase, you see the percent, or you see keywords double, triple, half-life. And then of course linear is increasing by the same number, it's a constant. So this is the kind of stuff that you have when you're looking at these three functions. All three very good functions.